In the previous video, one of the important take-home messages was that the rate at which the universe grows is dependent on the stuff that fills the universe. If the universe is filled with mostly slow-moving material, then the universe will grow at a certain rate. If the universe is filled with really fast, hot-moving, hot material like photons, the universe will grow at a different rate. Now, in both of these cases, we still arrive at the same unavoidable result. There was a time in the past, about 13.8 billion years ago, where the distance between every location in the universe was zero, and this is what we know as the Big Bang. So we could ask the question, what is the universe mostly made of? Is the universe mostly galaxies and stars, which would be cold material? Is the universe mostly fast-moving material like photons of light and neutrinos? Well, to answer that question, we can't just go out and count neutrinos and count photons. So what we would have to do is we measure the expansion rate of the universe, we learn about the expansion history of the universe, and then we see, is the expansion history of the universe better described by slow-moving material like stars and galaxies, or is it better described by fast-moving material like photons and neutrinos? Now, when I say slow and fast-moving, I mean slow or fast compared to the speed of light. So a galaxy could be moving at 1,000 miles a second. That's really fast, but compared to the speed of light, that is really, really slow. So we go out, we measure the expansion history of the universe, and we find that the expansion history of the universe was expanding, but then it was beginning to decelerate, but now the expansion of the universe is beginning to speed up again and go faster and faster. So the universe is growing larger, and the rate at which it's growing is also increasing. So we could say the universe is going through a period of accelerated expansion. Now, by acceleration, let's think of two ways I could count. I could count 1, 2, 3, 4, 5, or I could count 1, 2, 3, 4, 5, 6, 7, 8, 9. In both of those cases, the numbers were growing, but in the first case, the numbers were growing evenly. In the second case, the numbers were growing, but they were growing at an ever-increasing rate. The rate at which I counted was accelerating. And this is what seems to be happening with the size of the universe. The universe is growing bigger, but it's growing bigger at a faster and faster rate. So the conclusion from this is that the majority of the stuff in the universe isn't slow-moving material like atoms and galaxies and stars, and the majority of the stuff in the universe isn't fast-moving material like photons of light and neutrinos. The majority of the stuff in the universe is neither of these. So what is the majority of stuff in the universe made of? Well, essentially, from the Einstein field equations, we're basically trying to ask the question, what is T mu nu? What is some type of material that would cause the universe to get big at a faster and faster rate? Because slow-moving material like atoms don't predict the universe to get big faster and faster, and fast-moving particles like photons and neutrinos don't predict this either. Well, whatever the stuff is that fills the universe and makes up most of the universe, it's not normal material. It's not atoms, it's not light. So we can't directly observe what the stuff is. Even though we know this stuff makes up about 75% of the universe, we can only infer its existence based on the universe's expansion. We could see the effect that this stuff has on space-time. Remember the famous John Wheeler quote, "Space-time tells matter where to go, matter tells space-time how to curve." Well, we see the effect of the curvature of space-time. We see space-time getting bigger faster and faster, but we can't really see this material itself. So we infer the existence of this stuff based on the universe's expansion. Now, there are a very limited amount of things we can say about the properties of this new weird stuff we just discovered. So we could talk about how it dilutes, and this stuff seems to not dilute at all. So if you have some amount of stuff in a volume of space, if your space expands, you would have more stuff in that space. So think about the example with the chairs or the galaxy clusters when we double the side length of that cube from a previous video. If I quadruple the area or the volume of my universe, I would quadruple the amount of stuff in the universe that this is. So this new material doesn't seem to dilute at all. And that to the extent that we are able to measure, that is the best fit to the data we have now. Beyond that, there isn't really much we could say about this new material. So we say that the stuff that makes the universe grow larger at an ever-accelerated rate and accounts for most of the stuff in the universe today is dark energy. So in summary, we have dark energy. Dark stands for unknown, and energy stands for stuff. So dark energy basically is unknown stuff. Now, there are some proposed explanations that attempt to describe the nature of dark energy. Maybe dark energy is explained as a cosmological constant. Maybe dark energy is explained as quintessence. Maybe string theory has something to do with dark energy. Maybe chameleon particles or symmetrons, or there are a lot of different possible explanations for what dark energy might be. But at present, these are all speculative. There is really no evidence for what dark energy truly is.